Welcome to the deep dive. Today, we're really zeroing in on a core skill for anyone using C#. That's writing code that's not just working, but, actually clear and easy to understand.
Exactly.
You shared some great stuff from the Learn C# podcast about readable code. So our mission today is to pull out those key techniques, the really practical ones, that'll help you write C# code that's much clearer,
hmm
whether that's for teammates or, honestly, just for yourself 6 months down the road.
Yeah, absolutely. Think of it like establishing a common language for your code.
Right.
When it's readable, you cut down on confusion, things move faster, and it just makes fixing bugs or adding features way, way simpler later on. It's sort of an investment, really.
Couldn't agree more. And for you listening, this deep dive isn't about theory. We want to give you concrete strategies, things you can actually do right away to make your code, well, easier to grasp just by looking at it.
Yeah, practical tips.
It'll save you time, hopefully cut down on errors, and just make coding feel a bit smoother.
Okay, so let's get right to it. Why is readability like such a big deal in the first place?
Well, one of the core things the source material points out is this simple fact. Code gets read way more often than it gets written.
Huh. That's true, isn't it?
Yeah. You might spend, say, an afternoon writing a function, but that function could be read, I don't know, dozens, maybe hundreds of times over its life, people reading it to debug, to understand how it fits in, or when they need to change something.
Or just future you trying to remember what on earth you were thinking?
Exactly. So clear code is a direct benefit to everyone who touches it. And the material mentioned that scenario where code gets handed off to another team.
Right.
That really drives home the need for like a shared understanding, doesn't it?
It really does. Using conventions, writing clearly, it means everyone can get up to speed faster. It's about showing your thinking, not just giving the compiler instructions.
It's communication.
Precisely. Silent communication with other devs. And a really basic part of that communication is how we name things in our code.
Ah, variable naming.
Oh.
Okay. It sounds almost minor, but the source had that quote, something like, the hardest part of software development is naming things.
Yeah. Which makes you pause, like, why is that so critical?
Well, what's interesting is the split between the actual rules the C# compiler makes you follow for names
Okay.
and the, let's call them conventions that the developer community generally agrees on. The rules, those are the hard stops. Break them, and your code just won't run.
Right, like using letters and numbers, starting right, not using keywords.
Exactly. Alphanumeric underscores are, okay, got to start with a letter or underscore, though. That underscore usually means something specific, like a private field, no keywords. And crucially, C# is case-sensitive, so my value and my value are totally different things to the compiler.
Got it. Those are the lines drawn by the language itself. But then there are the conventions, the sort of unwritten rules. That's a good way to put it. They're the best practices that make code easier to read, even if the compiler doesn't care. Like the source talks about using camel case for local variables. This I is an example.
Right, lowercase first word, then caps.
Yeah, it's a visual signal. It helps you spot local variables quickly. But maybe even more important is choosing names that are really descriptive, names that tell you about the data inside.
So not just flag, but maybe is order complete.
Exactly. Is order complete tells you so much more than just flag or status.
What?
Or even worse, some cryptic abbreviation.
Yeah, and the source mentioned using whole words like order amount is better than odrampt.
Definitely. Saves the next person trying to decode your abbreviations.
And it also warned against putting the data type in the name, like string, strizzer name. That feels a bit old school now.
It is, yeah.
Yeah.
Generally, you want the name to reflect the variable's job or purpose in the logic, not just its technical type. You can usually see the type anyway when it's declared. So these conventions, they're not enforced, but they create consistency.
Which makes the whole code base easier to navigate for anyone.
Right. And the source notes this mainly applies to local variables inside methods. Other things, like class names or method names, might have slightly different conventions.
Okay, that makes sense. So careful naming is job one for readable code. Let's shift gears to another communication tool, comments.
Comments, yeah. So these are basically notes the compiler just ignores, or
Yeah.
is marked with, usually.
Right.
The source highlights maybe three main good uses for them. First, explaining the why behind a chunk of code. Not just what it does line by line, but the reasoning, especially if the logic is a bit complex or non-obvious.
So the intent.
Exactly, the intent. Good comments explain why, not how. The how should ideally be clear from the code itself if it's well written. Second, they're handy for just temporarily disabling code, commenting out a few lines while you're testing something else. without deleting them.
Oh, yeah, I do that all the time.
We all do. And third, using those Tododo markers, like Tododo. Need to refactor this later. It's a good way to leave reminders for yourself or others.
Those all seem like solid reasons. But the source also talked about low-quality comments. What makes a comment bad, then?
Usually it's comments that just repeat what the code already says, very obviously. Like you have count plus plus, and the comment next to it says increment count.
Yeah, okay, that doesn't add much value.
Right, it's just noise. It
Yep.
clutters things up, and worse, it can get out of sync. Someone changes the code but forgets the comment.
And now the comment is actively misleading.
Exactly. So avoid commenting on obvious single lines. It's much better to use comments like the source suggests for a higher level purpose, like explaining the overall goal of a whole section of code. The fraud detection process example they mentioned is a good case for that. A block comment explaining the strategy.
Okay, so summarize the big picture, not narrate the tiny steps. That makes sense. But then there was that really strong warning, never trust comments. Wow, why so blunt?
Well, it sounds harsh, but it's a necessary caution, I think. Comments are written and maintained by humans. Humans make mistakes, forget things. So a comment might say, the code does one thing, but maybe the code got changed, and now it actually does something else. So while good comments help you understand the intended purpose, you always have to treat the code itself as the final word on what's actually happening.
The code is the ultimate source of truth. Got it. Okay, names, comments. What about something the compiler totally ignores, but humans definitely don't? Whitespace.
Yes, white space, spaces, tabs, new lines, all that empty stuff. To the C# compiler, it's like it doesn't even exist. You could write your whole program on one giant line.
Please don't.
Haha, no, definitely don't. But for us reading it, how we use that white space is absolutely critical. The source made a nice comparison to graphic design, right? Using white space or negative space to avoid just overwhelming the eye and to guide focus.
That's a really good analogy because staring at a solid wall of code, it's exhausting.
It is. And those examples in the material, the jammed together console,
Yeah.
right line calls, or that dense dice rolling code,
Oof, yeah, hard to read.
they really show how lack of spacing makes it tough to see the structure, to see where one thought ends and another begins.
So what are the key ways we should be using whitespace effectively?
Okay, several key things. First, the absolute basic. Put each complete statement on its own line. One command, one line. Creates that vertical flow.
Simple enough?
Then use vertical whitespace blank lines deliberately. Use them to separate logical blocks of code. Like in that dice example, you could put a blank line between setting up the dice object, then the lines where you actually roll the dice, then another blank line before calculating the total.
Ah, so you're creating visual groups.
Exactly. Grouping related actions together, it breaks the code into digestible chunks.
What else? Around operators.
Yeah, using spaces around operators, especially the assignment operator, the equal sign,
Yeah.
it just makes it less visually cramped. XSY plus 5 is easier on the eyes than XY plus 5.
Little things, but they add up.
They really do.
Yeah.
And then there's how you format code blocks the stuff inside curly braces, like in if statements or loops. The standard practice is putting the opening brace on its own line, and the closing brace on its own line too, lined up with the if or for or whatever start the block.
Okay.
And crucially, indentation. Everything inside those curly braces gets indented, usually by one tab or set number of spaces.
Yeah, it shows the hierarchy, right? What code belongs inside what block?
Precisely.
Yeah.
That nested ifelse in the dice example really showed that. You can instantly see which code runs based on which condition because of the indentation.
So it's all about visual structure, helping our brains parse the code faster.
That's the goal. And yeah, the source did mention that people might have slightly different preferences, like maybe exactly how many spaces to indent.
Sure.
But sticking to these general principles, new lines, blank lines for grouping, spaces around operators, braces on new lines, indentation gives you a really solid, consistent base for readability.
Consistency is key, especially on a team. Okay, to make this really concrete, the source had that code readability challenge. Can you walk us through that? The before and after.
Sure. So the before code,
Mm-hmm.
its job was two things. Reverse a string
Mm-hmm.
and count how many times the letter O appeared in it.
Okay.
But it was written, well, pretty poorly from a readability standpoint. You had really short, kind of meaningless variable names,
Mhm.
street R, charm message X, new message. You weren't quite sure what held what.
Yeah, cryptic.
And it had those inline comments just saying obvious stuff like convert message to char array. We already see that happening in the code.
Redundant, yeah.
Plus, it was all jammed together, almost no blank lines. Indentation might have been messy.
Yeah.
Just a dense block.
Hard to follow the flow. So how did the after version improve things?
Big difference. First, the variable names were much better. Original message, message, presumably the char array, letter count, new message. Instantly clearer what each one is for.
Much better.
Those unhelpful inline comments. Gone. Replaced by a single high-level block comment at the top explaining the overall purpose of that whole code section.
Nice. The why, not the how.
Exactly. And then strategic use of blank lines. Separated the setup, the loop, the final output maybe, just breaking it up visually. And the formatting of the loop, for each, and the if statement inside it was cleaned up braces on their own lines, proper indentation, made the structure immediately obvious.
It sounds like night and day, really. Just much easier to understand at a glance.
Totally. And like the source said, that specific after code is just one way to do it well.
Hmm.
Someone else might put a blank line in a slightly different spot.
Right. Minor style differences.
But the cool principles, good names, helpful high-level comments, using whitespace and indentation properly, those are what made the real difference.
Yeah, the impact of those small things is actually huge when you add them all up.
It really is.
Okay, so wrapping this up then. For you, the learner, listening in, what are the absolute must-remember takeaways from this deep dive on readable C#?
I think the big thing is understand that these aren't just like optional extras.
Wrong.
Choosing good descriptive names, writing comments that explain your reasoning, and using whitespace deliberately to structure your code. These are fundamental. They're not just about making code look pretty. They directly impact how easy it is to collaborate, how easy it is to maintain the code later. Ultimately, they make you a more effective developer. It saves time and headaches down the line.
Definitely. And as you keep coding, try to consciously think about these things, apply them to your new code, maybe even, look back at an old project, see where you could improve its clarity using these ideas.
That's a great exercise.
And digging into the official C# coding conventions might give you even more detail, too.
Yeah, good idea. And maybe a final thought to leave you with. Remember that the code you write isn't just for the computer, it's a message. It's you explaining your solution to your future self, to your teammates. So focusing on making that message clear, focusing on readability is a really worthwhile investment. It pays off in the long run.
So, what other parts of crafting really clean, understandable code might you want to explore next? Something to think about.